Alright, so this lecture is going to be about microscopes, a little bit about different kinds of microscopes, but with a focus on the compound light microscope, which is the one that you're going to be using in class. And you definitely need to know the basic parts of this microscope and how it works, because we'll be using it not just right now as an introduction, but to study things like cells, to look at protists later in the year. So the light microscope is something we will use throughout the year, so you need to definitely know a little bit about it. So the light microscope, or the compound light microscope, is what most high schools have, and it does a great job of magnifying specimens that we would generally look at in a classroom. It can magnify, ours can magnify 40 times, 100 times, or 400 times, but they can't magnify as much as what are called electron microscopes, which we'll talk about in a few minutes. So there's also something called a stereoscope, or a binocular microscope. It looks kind of like this, this picture on the slide. It only magnifies 10 to 20 times. This is something you might use more in anatomy. Like if you were going to be looking at, say, the movement of some bugs, or look at a sheep eye or some tissue samples, you would use this because it only magnifies a little bit, but it does give a nice three-dimensional view of the specimen, so this is great for anatomy. But for our class, you don't really need to know about this type. And then there's these microscopes called electron microscopes. So the scanning electron microscope lets you magnify up to 2 million times. So you can see these beautiful pictures. It's three-dimensional pictures. You see the results on a screen. But this is not a type of microscope that you would use in high school. And in fact, you might use it in college, but only after you even take a course in how to use it. Because scanning electron microscopes, as well as transmission electron microscopes, which is what this is a picture of, they're huge. They're these really big microscopes that use electron beams hitting the specimens in order to see them. But they do allow us to see things as tiny as viruses. So these are amazing microscopes for what they do, but they're not the kind that you would use in class. The difference between the scanning electron, by the way, and let me go back to this picture. The scanning electron scans the surface, so see how these are beautiful three-dimensional images? The transmission electron microscope actually shoots the beam of particles through the specimens. It has to be thin slices. And the nice thing about the transmission electron microscope, it's allowed us to see inside of cells. And so some of the parts of the cell that were never even discovered were actually discovered as a result of the scanning and transmission electron, particularly the transmission electron microscope, because it allowed us to see things much, much smaller than what a light microscope can pick up. This is just showing that there's different kinds of illumination, different kinds of lights that would change your view of specimens. We just have a plain light microscope that's going to give us bright fields, sort of like these two pictures on the far left. They are nothing special, it's just a regular white light. Some of these other ones use special types of light in order to allow you to see a little differently, and it might allow you to see details that we might not be able to see in class. Okay, some guidelines. Number one, whenever you're carrying the microscope, you use two hands, one underneath the bottom or the base, one to hold the arm or the side. I'll show you those parts in another slide. You also don't want to clean it with like a paper towel because you could scratch the lenses. You don't want to force any knobs. Anything that's not turning, there's probably a reason for that. We cover them when we store them. Obviously, you don't want to trip over the cord. These do plug in. All right, as far as the parts, you're not going to need to know every single microscope part, but I want to focus in on just a few of the really important ones that you definitely want to know. So the eyepiece, this is what we're looking through, and this magnifies 10 times. Now down here, these are objective lenses, and you actually turn this nose piece, and you can use these different objective lenses, which we'll talk about their magnifications in a minute. So your total magnification is actually going to be 10 times for your eyepiece times whatever objective lens you're using. So for example, if I'm using the 40x objective lens, 10 times 40, I'm actually getting a total magnification of 400 times. And this is also why it's called a compound microscope, because it has two lenses, an eyepiece and then an objective lens. So there's two magnifiers there. Okay, you also need to know the stage. This is where we're putting our specimen, is right here on this stage, or it'll actually go on a slide underneath these little clips, which are called stage clips. There are two adjustments here, the coarse focus and fine focus. The coarse focus, it churns that stage a lot. It really moves things. The fine is more for fine tuning. It moves things just a little, and this is perfect for getting something in focus when it's almost there. But the coarse adjustment you typically use first. The base, of course, is the bottom. The light shines up from the bottom like this, and that's where this comes in. This diaphragm here, it turns, right? And if you were to look at it from underneath, it would look like this. It's like a disc, and it's got these different size holes in it. And the reason that you would use the diaphragm, especially on this particular microscope where it only turns off and on, so the light comes through very bright. You might be looking at a really thin specimen, and if the light comes through really bright, your specimen's going to be really washed out. You're not going to be able to see anything. So what you can do is you can turn this diaphragm to one of the smaller holes. So now the light comes up from the bottom. So here's our light coming up from the bottom. And this diaphragm here, it can only pass through this little bitty hole to get to, here's our stage. Now the amount of light that's actually penetrating to our specimen is much less. Whereas if we want to look at a really thick specimen, it might be really dark. And so you open this diaphragm to the biggest hole, the most light comes through, and then you can illuminate your specimen. So these are the main parts that I would want you to know. The stage, the eyepiece, the objective lenses, the coarse and the fine adjustment, and then the diaphragm for focusing how much light can come through. Now as far as magnification, again, you should know that the ocular lens or the eyepiece, ocular means the same thing as eyepiece, always magnifies 10 times on all of our microscopes. But depending on which one of the objective lenses you're using, you would multiply that out, and that's going to give you your total magnification. They are called scanning. This is going to be the shortest one. If you look back here at this kind of messy picture now, these are different lengths. So the way you're going to know, they actually do say on them 10 times, 100 times, but the shortest one is going to magnify the least. So as they get longer, so the scanning is going to be a little one, the low is going to be longer, and then that high power is going to be a really long lens. In fact, it can almost touch the slide when it's turned facing down. You're using that one. All right. Simple rules for using the microscopes. Obviously, put all of your stuff out of the way. It says to use extension cords. In my room, we have plugs right there at the desk, so we won't need to use extension cords, so you don't need to worry about that. The cords are usually wrapped around the microscope, so you're going to want to obviously unwind that. And again, anytime you're carrying it, you're going to hold it underneath here, one hand down here, holding that base. And then the other hand is where you're going to grab it right here, like that. And that's how you're going to carry it. So one hand around this arm, one hand underneath the base. All right, once you put your slide underneath, you're always going to want to start with the scanning, the shortest objective lens. And that's because that scanning lens is actually going to give you the biggest field, and you'll be able to see probably something. It may look really blurry, but you'll probably be able to see something. And then you can use the coarse adjustment knob. Remember, that's going to be the bigger knob. And you can sort of turn that until you get your slide in focus. If you can't get the object completely in focus with the coarse adjustment knob, you can use that fine adjustment knob to fine tune it once you're almost there. They suggest not putting your specimen under the stage clips right away because you may need to move your slide around. And then when you get it where you think you're seeing something, then you can put it under those stage clips and that'll hold it in place. All right, again, once you've got it in focus with the scanning power, if the microscope is set up correctly, cross our fingers, when you switch to low power, you probably won't have to refocus much. Everything will pretty much be in focus. It might be slightly blurry, and then you just sort of tweak it, and then it's back in focus. And then finally, you're going to switch to high power. Now, once you're on high power, well, before we even go there, if the slide is really thick, then you probably don't even want to use high power because, again, as I've mentioned, the high power objective lens looks like this, and it kind of comes down here, and it goes super, super close to the stage. So if you actually have a really thick slide and you try to put it on high power, you'll end up cracking the slide. So that's not going to work. But if you have a thin slide, you can go ahead and switch to high power, but you never, ever, ever want to use the coarse adjustment. You want to only use the fine adjustment. Because again, if you turn that really big coarse adjustment knob, it's going to move the stage very quickly. And without realizing it, because you're looking through the eyepiece, this stage is going to get too close and you're literally going to crush the slide. You're going to have a bunch of broken glass. So be really careful. Keep this in mind. You can use the coarse adjustment for scanning in low. Only use the fine on high power. And always start with scanning and then work your way up to high power. If you start on high power, you're going to have a hard time getting anything, seeing anything, getting anything in focus because it has to be so fine-tuned to see on high power. It's just not going to work out. All right. Again, this is the same thing over again. Make sure you're focused on low before you go to high power. Never use the coarse adjustment on high power because you can crack the slide. Okay, making a wet mount. So one of the things you're going to do in this lab is you're going to make a wet mount slide. So to make a wet mount slide, we're actually going to make one of just simply a letter E. You keep it very simple for this particular activity. So what you would do is you'd put your letter E on the plate. They make it look here like you put the liquid on first, but you actually don't. You put your specimen on first, 1 drop of your liquid, then you're going to put your cover slip on, and then you're ready to go. Now, super important, you do not want to put your cover slip on directly flat. In other words, you don't want to do this. You don't want to have this and then just take that cover slip and just lay it flat on there. What you want to do is put it on at an angle. And the way you're going to do that is start with the cover slip sort of like this, tilt it up so that it's touching the liquid here, and then slowly lay it down like this at an angle. Why? Because if you take it and you put it flat, what's going to happen is you're going to be looking through the microscope, your cover slip is here, and you're actually going to see a bunch of perfect circles that may even look like they're moving around. People always are like, oh my gosh, I see something moving. And what you're looking at are air bubbles. So you don't want to do that. So if you put it on at an angle and then slowly lower it down from that 45-degree angle touching the liquid, you tend to push out any excess air, and then you get a nice, perfect view of your specimen. All right, and then last slide, quick troubleshooting guide. If the image is too dark, 2 things you can do. Number 1, make sure your light is on. Always get a few people that can't see anything. They never turned on the light. Second, adjust the diaphragm. Remember, that's the little disc under the stage. It's got different size holes, and you can open it to the biggest hole that's going to let the most light through. Second, you're seeing spots through your viewing field. It's very possible you're looking at dirt. So we want to use lens paper. I actually have also some Q-tips, and we'll carefully clean those lenses and hopefully get off any kind of dirt or dust. High power, you can't see anything. Remember, in order to see on high power, your high power lens is going to end up like this, like so close that it's almost touching your slide. So you don't want to start with high power. Definitely don't start with it. But if you start with scanning and you get to high power and your high power lens is basically here and then here's your stage and you see a big gap, I can guarantee you that's why you're not seeing anything. Because when you're close to being in focus with high power, that lens is almost touching the slide. So you want to start at scanning, work your way up. Your slide might have moved. Your specimen might be off to the side, and high power is so specific, your specimen would have to be right in the middle. Call me over. I'll be glad to help you. Sometimes you see this, where it looks half dark, and you're like, all I see some of my slide, and then I see all this black. Usually what's happened there is you don't have the objective lens in place. It hasn't clicked in place, or you have the diaphragm not fully opened. That diaphragm under the stage is not fully opened to an actual hole. You have it like halfway between 2, so only some of the light is passing through. Bottom line, you can always call me over to help you, and I can make sure that we get everything all set up. We're not going to label the parts right now. Remember the ones I'll run through really fast that you definitely want to know. Eyepiece, objective lenses, your stage, your coarse adjustment, fine adjustment, the diaphragm under here, everybody forgets, and then the lamp. And then, of course, just for carrying purposes, the base, you put your hand under the base, and you hold it by, this is called the arm. And I know I went through that really quickly, and we're not going to do these practice questions. So that should be a quick guide to the microscope.